Hi, welcome to our discussion about alkynes. So, alkynes are less commonly known than alkenes. Pero, alkynes are also found in both lab and living organisms. So, what are these alkynes? So, earlier in our semester, napag-usapan na natin that alkynes are hydrocarbons that contain a carbon-carbon triple bond. And the general formula here is CnH2n minus 2. So if you use this formula, assuming that there is no other substituents like chlorine, bromine, or other mga substituents, you will find out the molecular formula of a particular alkyne with the n number of carbons. So like for example, if you have 5 carbons and there's a single triple bond there, so you just input the value n equals 5. So 2 times 5, so that's 10 minus 2, so that's 8. So the molecular formula for an alkyne with 5 carbons will be C5H8. Here, acetylene is considered as the simplest alkyne, and it is produced industrially. So binamass produce ito industrially from methane and steam at high temperature. So we say methane, that's CH4, and we have steam, that's just water, and at very high temperature. So after that, you will now have your what's the formula for acetylene? So acetylene, you need 2 carbons, so that's C2. So how many hydrogens are there? So 2 times 2, 4 minus 2, so we have 2 hydrogens. So yung simplest natin na alkyne will be 2 carbons, and then there is hydrogens attached to it. So this is acetylene. So acetylene is also, dapat maging familiar din kayo with acetylene because it is also used for a starting material for a wide variety of organic compounds. So like acetaldehyde, we have also acetic acid, so just vinegar, and a lot more of organic compounds. So ano ba tong acetylene gas na to? Acetylene gas is a gas that is burned at in high temperature oxyacetylene welding torches. So usually pag narinig natin yung acetylene, ang una nating naiisip is welding torches. So ito yung ginagamit para para tunawin yung mga bakal. Kaya in the future, kapag naging pulis na kayo, minsan may mababalitaan kayo na may mga bangko na ninanakawan kasi ginamitan nung mga magnanakaw nung acetylene. So, yun yung tinatawag natin mga acetylene gang noon. Okay. So, our study of alkynes is important because it will provide an introduction to organic synthesis. The preparation of organic molecules from simpler organic molecules. Just like yung acetylene natin, that's C2H2, yan ay pwede natin gamitin para makakreate tayo ng iba pang mga organic compounds. So that's why there is touch of organic synthesis. So naming of alkynes, I will skip this because I already mentioned this earlier. There's a separate video wherein I discussed yung ating naming of alkynes. So if you want to watch another round of videos, so you click this link and then watch the video. Also, yung properties ay napag-usapan na din natin I remember dun sa discussion natin ng alkenes, I already mentioned some properties. And similarly, may similarity yung properties ng alkenes and alkynes. So they are both nonpolar compounds. So I have mentioned this last time. And yung alkenes and alkynes natin are insoluble in water. You know that water is polar. And you should know and you should remember that alkynes are nonpolar compounds. So if you try to mix a nonpolar and a polar compound, they will never mix. But it will be soluble in one another. So if you have two alkynes or an alkene and alkyne, they will be soluble. Also, if your solvent is non-polar. So, kung natandaan nyo, meron tayo na tinatawag na like dissolves like. So, if your solute, yung i-dissolve mo ay non-polar, dapat para ma-dissolve siya, gagamitan mo din siya ng non-polar na solvent. Okay, so alkenes and alkynes are liquid or solid at room temperature. And they have densities less than 1. So 1 gram per ml, that's the density of water. So density of water, since the density is less than 1, so what will happen to alkenes and alkynes? They will float on water. So they will float on water and they will not dissolve. And hindi nga sila magdi-dissolve. Kasi nga, the basis is like dissolves like. And you're dissolving a non-polar solute, your alkynes, with a polar substance like water. So hindi sila mag-mix. They will just float sa water. And then there will be phase separation. So if this is water, nandito yung inyong alkynes. So magpo-float siya. So there's a phase. So makikita mo na two-phase siya, two-phase. Phase. One phase for the water and one phase for the alkynes. Now, how do we prepare alkynes? So, alkynes, yun nga, may triple bond siya. So, we start with an alkene. So, treatment of a 1,2-dihaloalkane with potassium hydroxide or sodium hydroxide. So, KOH and sodium NaOH, these are bases. So, bases yan. And, in the process daw, they will produce a twofold elimination of HX. So, again, HX, the X here will refer to the X, the halogen. So, your halogen can either be chlorine, bromine, iodine, and ano pa ba? Fluorine. So, we have here a term, vicinal dihalides are available from addition of bromine or chlorine to an alkene. So, anong ibig sabihin nito? If you start with an alkene, and then naglalagay ka ng bromine, or chlorine, or ng halogens, magkakaroon ka ng vicinal dihalides. Ano ba ibig sabihin nitong vicinal dihalides? So, vicinal dihalides, eto siya. One example is this compound. As you can see here, the bromine, may dalawang bromine in the compound. But where is the position of your bromine? Your bromines are located or attached to two different carbons. So this compound is now a vicinal dihalide. Meron siyang isang counterpart called a geminal dihalide. So ano naman tong geminal dihalide? If for example, you have a carbon and you have here two halogens attached to that same carbon, that is a geminal dihalide. You remember Gemini? So the constellation Gemini, that's the twin. So twins, yan. So doon nila kinuha yung term. So it seems na parang may twins ka dyan. The twins here are your halogens and they are on the same carbon. So paano ba nangyayari yung formation ng inyong alkynes? So, sabi nga, you start with an alkene. So, you have here a double bond. So, you just focus on this part or portion of this organic compound. So, with the addition of bromine, that's Br2, this is bromination. So, bromination, what will happen here is, you will be adding bromines here and here. Yan. So, the double bonds here will become one. So, single bond na lang yan. So, yung after, yung carbon-carbon double bonds mo ay magiging carbon-carbon single bond na lang, meron kang kailangang dagdag na bonds. So, dito natin ikakabit yung bromines nyo. Kaya, ano nangyari? The bromines are added in in this fashion, in this way. Kaya pala siya tinawag na vicinal dihalide. Remember, vicinity. Pag sinabi mong, I'm in the vicinity of this place, ibig sabihin, malapit lang. So, yung bromines natin dito, dahil, they are found on the same compound, pero medyo, magkalapit lang sila in the vicinity ng isa't isa. Kaya, we call this a vicinal dihalide. Specifically, this is called a vicinal dibromide. Bakit siya naging dibromide? Kasi nga, bromine yung nilagay natin dito. Okay. So, now, sabi, the treatment of a 1,2-dihaloalkane. This one is a dihaloalkane. Isipin nyo lang, meron siya ditong ito, yung benzene ring. May dalawang benzene ring, tapos meron kang bromines. Pero itong itong parent compound, parent chain natin dito is 1,2. So that's why it's called met-et. So ethane. So meron ka nung 1,2 dibromo. So meron kang bromine at carbon position 1 and 2. Meron ka din nung tinatawag na phenyl group, yung benzene ring, yung benzene, ang tawag natin dito is a benzene ring, pero pag ginamit natin siya na substituent, ang tawag natin dyan is phenyl. Okay, so meron tayong phenyl, 1,2-diphenyl ethane. So bakit naging ganito pala yung pangalan niya? Dahil parehas natin silang ginamitan ng, hindi naman kasi nagmamatter naman, di ba, yung di, yung prefix na di, so mas mauna pa rin talaga lagi yung bromo, then phenyl. Kaya the name is 1,2-dibromo, 1,2-diphenyl ethane. Now, sabi dun sa first bullet, the treatment of a 1,2-dihaloalkane with a KOH or NaOH will produce the two-fold elimination of your HX. So what is our HX here? Yung X dito is bromine. So itong compound na to, kapag yan ay ating ni-react with KOH, what will happen? Mare-remove itong part na to. I need to change the color. So this will be removed. The H and the BRs. So dahil meron kang dalawang set na yan, you will remove this as yan. So magiging siya, KBr. So bakit siya naging KBr pala? So your KOH, yan, KOH plus the BR, so mag-react with each other. So KBr, and then meron ka ding additional na formation of water, HOH, ito. So para magpapalitan sila ng partner. So HOH, that is only water. So meron ka dito maproproduce na dalawang KBr and then dalawang water. So what will happen to the vicinal dibromide? It will now become a triple bond. So from alkene, naging alkyne siya. Okay? So if you want to watch watch videos, so ito pwedeng yung panoodin. This is about preparation of alkynes, so halogenation and dehydrohalogenation. So dito parehas bromine yung class. Parehas na bromine yung inalis. Dito naman sa part na to, ang pwede nyong alisin is the H and the Cl. So itong process naman na to, ang tawag naman natin diyan is, pag inaalis natin yung H and the Cl, we call that dehydrohalogenation. Why dehydrohalogenation? You're removing the H and you're removing the halogen. So that's why this is called dehydrohalogenation. Etong part na to, para dun sa ating first example, this is just halogenation. Yan. Inaalis natin yun. Okay? So ito, halogenation. Itong step na to, halogenation. Diba ang weird niya? Naglagay ka ng halogen dito, tapos later on, tatanggalin mo din siya. Okay. So itong sa second example natin, we have here H and the Cl. We can remove this H and Cl. So what will happen is, matatanggal yung HCl. So meron tayo yung magiging product na HCl. And this remaining part of the remaining part of the compound will become a triple bond. So meron kang triple bond, and since there's OH here, magiging alcohol siya. So yung magiging pangalan ng inyong compound is meron siyang aspect containing the triple bond and the alcohol. That's why you have here an ol. Okay? So ito din. So we have alkyne synthesis naman by elimination of dihalides with sodium amine. So you can watch this video. So we'll go now with the reactions of your alkynes. So ang gagawin natin dito is parang pabalik tayo. Yung kanina, nag-start tayo with alkene, tapos naging dihalide siya, vicinal dihalide siya, then naging alkyne. This time, baliktad. Yung ating starting material will be an alkyne, and we will try to react with different reagents. So the first one is the addition of HX and X2. So again, HX here is your halogen na may hydrogen. So this reaction is called your halogenation. Kapag X2 lang yung nakita nyo, that is a halogenation reaction. So addition reactions of alkynes are similar to those of alkenes. So napag-usapan na natin yung mga reactions last time. So since we are starting with an alkyne, the intermediate will be an alkene. When say intermediate, yan isa yung product. Pero pwede itong product na to, pwede pang mag-react with your reagent to form another product. So, somewhere in the middle siya. So, that's why it's called an intermediate. So, the intermediate alkene here will become an alkane. So, parang pabalik na tayo. So, from alkyne, magiging alkane naman siya. And also, we will apply here radioselectivity according to Markovnikov. Ano nga yung sinasabi ni Markovnikov? Kapag meron kang H na kapag ang rule niya dito, kung sino yung mas yung carbon with less hydrogen, doon mag-a-attach yung hydrogen mo. At kung sino yung mas madami yung hydrogen, doon mag-a-attach yung isa pang portion ng iyong reagent mo. And since ito naman ay bromine lang, so BR lang siya. So meron tayong mahati yung molecule, yung Br2 into two BRs. And paano mangyayari? Ang mangyayari dito, class, is yung Br natin will react on this sides. So one side and the other side. And so bromination natin, i-subject natin itong alkyne natin with bromination. So what will be the product? The product will be anong product natin dito? The product will somehow look like a trans. So bakit siya trans? Kasi yung bromine natin is opposite each other. Or if you apply the E-say system, yung ating yung substituent dito na may mas mataas na molecular weight is yung Br. So, di ba, hinahati natin yon. So, ito din, mataas yung Br compared sa H. So, nasa na position ng mga Brs natin? Yung bromine natin ay opposite each other. So, that's why it's a trans. Ngayon, if you have an excess of the bromine, Br2, what will happen? Your Br will react with the double bond. So, that's why magkakaroon ka dito ng 4 na bromines. So, if you started with an alkyne triple bond, if you continuously react it with the halogen, magkakaroon ka in the end ng tinatawag na tetrahalide. So, when saying tetrahalide, meron kang 4 na halogens na naka-attach dito. And, Take note, this is now an alkane. Ngayon, so ito naman yung sinasabi ko nga sa inyo, initial addition will give you a trans intermediate. And if you will react the product, yung ating intermediate na alkene, the alkene product will react with the excess reagent, it will now become a tetrahalide. So yung susunod na example dito is paano kapag yung ang i-add natin doon sa inyong alkyne ay HX.